Hello, this is Andy from the Engineers Academy, and in this video tutorial we're going to be looking at some of the advantages and disadvantages associated with the use of computer-based modelling techniques in engineering. Now, before we get onto the advantages and disadvantages, it's first of all important to understand what we mean by computer-based modelling techniques and how they can actually be applied in engineering. So we're going to begin by answering two important questions. First of all, what are computer-based modelling techniques? And secondly, how are computer-based models used in engineering? So something that most of you are probably already familiar with is computer-aided design, or CAD. And CAD has come a long way in recent years. Models are very rarely generated as 2D designs now. They're more often developed as 3D models, and the 2D design drawings can then be drawn from the model if they're required. So this is one aspect of computer-based modelling that we need to be aware of. In addition to computer-aided design, we have computer-aided engineering, CAE. And there's two key aspects to this that we're going to be discussing. The first is finite element analysis, often referred to as FEA, and computational fluid dynamics, which is often just abbreviated to CFD. Now, we're going to be discussing these in a little bit more detail, but essentially what we can do with these computer-aided engineering techniques is make predictions or calculations around where things such as principal stresses might occur, or we can also look at flow parameters for, say, a fluid travelling through a pipe or a duct. So they're very useful techniques to start to understand other elements of our engineering design process. So in the top right hand corner we have an example of how finite element analysis might be used, and here we're looking at where the principal stresses occur on this particular rotor. And we can see that the principal stresses in red occur at the root of each of those blades. Our second example here is for a fluid flowing through a Venturi tube. And what we can see is that at one side of the Venturi tube we have turbulent flow, and on the other side we have laminar flow, but we can also begin to explore the fluid velocities through that duct. So now we understand a little bit more about what we mean by computer-aided design and computer-aided engineering, we need to start to consider how this might be used within engineering. Now, obviously the two primary areas are for engineering design, so producing designs of engineering components, but also for elements of research and development. If we want to improve or enhance an engineering component, we need to start to understand how changes to that design might affect principal stresses or might affect flow through a duct or flow around an object. Now, another huge benefit, particularly of computer-aided design, is that we can now produce rapid prototypes of components. And a rapid prototype is a physical component that's identical to the final component, except it's made out of a resin or a different material. Now, this is excellent if we want to see how two components are going to mate, or whether a new component is going to fit in with an assembly, and it saves the expensive costs of manufacture, yet we can still hold that physical component and we can actually physically see how it's going to assemble with other components without the high costs associated. And following on from that, we have computer-aided manufacture. Now, once again, we produce models in engineering through CAD or computer-aided design, and those models hold the geometries for our components. Now, what we can do is we can actually export them, and we can use those with CNC machines in order to produce our physical components from the models. Rather than providing an engineering manufacturer with our component drawings, we can provide them with the physical models so that they can interrogate those models and produce our final components from those models. So next, let's consider some of the advantages and possible downsides or disadvantages associated with using computational modelling techniques. Now, one of the first things to consider is the computation requirements, and by that I mean the specifications of computers required in order to carry out these calculations, and also the time associated with computation. We're going to see in later tutorials how we define these problems, and depending on how we define those models determines how long they're going to take to run in order to generate our solutions, and also the amount of computation power that's going to be required in order to generate those solutions. So this brings us on to cost, and I've indicated there that this might be costs in terms of time or financial costs associated with the adoption of these computer-based modelling techniques, as well as training for individuals who are going to be using them. Naturally, these software options are not free of charge for commercial use, however they are free for educational purposes. We have to appreciate that these techniques not only take time to learn, but it's important to be prepared to continue learning and developing your understanding so that you remain a competent person in the use of these techniques. Now, we've already mentioned some examples of problems that could potentially be investigated or solved using these CAD and computer-aided engineering techniques. When we revisit the two examples below of the flow through the duct and the stresses on the rotor blade, it's important to consider how we would go about solving these problems, or at least investigating these problems, if we didn't have access to computer-aided engineering techniques. Now, there's various different traditional methods. So for the problem on the left-hand side, we may need to construct a wind tunnel or something similar so that we can analyse the flow through this particular duct. We could also use various instrumentation to measure pressures and velocities at different points. But what that doesn't enable us to do is to physically see and understand how the fluid's flowing through that duct. Now, the same is true with the example on the right-hand side. If we wanted to investigate this without the use of computer-aided engineering, we would have to have a relatively complex and expensive setup incorporating strain gauges to measure principal strains, and then this could translate into stresses on that particular component. But don't forget, in order to do those things, we would first need to manufacture the component, and if small adjustments were required to that particular design or that particular component, again we've got the costs associated with remanufacturing and retesting. So hopefully this serves to highlight that there certainly is a place for these computer-aided engineering techniques, both in design and research and development. Now, we mentioned earlier that computer-aided design itself has evolved quite a long way, and we've moved from 2D designs to 3D models, and the 3D models are used to generate the 2D drawings as and when they're required. Now, if we go back even further than that, these 2D and 3D drawings and models would have been produced by hand, which not only is very time-consuming, but it's very difficult to make the adaptations if we decide to redesign or remodel a component. Now, another excellent feature within the software that we recommend, Fusion 360, is that there's an integrated off-the-shelf component library. So here we see that we can access component libraries for lots of different off-the-shelf components. It might be bolts and screws, it might be washers and nuts. But the important thing here is when we access that component library, we can actually pull a CAD model of that component out of the component library, and we can integrate that into our design. What this means is we don't need to be drawing bolts, nuts and washers, but we can also make sure that our own component or assembly is designed correctly in order to accommodate those components. There's also the option to purchase these components through the component library, which again just streamlines the whole process. Now, one thing we do need to be careful of is it takes a certain amount of time, training and competence in order to understand and interpret the models that we're creating. And that's not just for the computer-aided engineering models, although it's probably more apparent there. If we generate a set of results showing stresses or fluid velocities or temperature profiles, then the person interpreting those results must have an understanding of what those results are actually telling us. Now, another advantage of all of these software options is model compatibility, and what that means is we can import and export our models into different software. So if an individual produces a CAD model, for example, and then they want another individual to interpret that using finite element analysis, then those models can be imported, allowing different individuals to work on that particular project. Now, we've already mentioned rapid prototyping and computer-aided manufacturing, and these are huge benefits of using the computer-aided modelling approach over traditional techniques. Now, the final consideration is how we share these models with non-CAD and non-computer-aided engineering users. We've already spoken about the importance of being competent in order to understand and interpret these models, but what if you want a component manufactured and the company that you're dealing with don't have access to computer-aided design and computer-aided engineering techniques or software? Now, once again, Fusion 360 does have the capacity to enable individuals without the software to interrogate the models, but once again, we do need to be careful that the person interpreting the model is a competent person. As we move forward, the likelihood is that most manufacturing or prototyping companies are going to be adopting these techniques into their processes, so the likelihood of working with companies who don't have access to CAD and CAE systems is likely to become less and less of an occurrence. So just to summarise, in this video we've introduced computer-based modelling techniques and we've looked at some of the advantages and disadvantages associated with their use. In the next video, we're going to look more specifically at these computer-aided engineering techniques of FEA and CFD, and we're going to look at how the models themselves are used in order to generate results.